Okay, so we are getting ready to start genotyping assay, and this is a setup we use to set up everything. We're using a 384 well plate, and we are going to do allelic discrimination. We are going to run this assay in the real-time PCR machine, 7900 HT fast real-time PCR, and it has a manual. If you follow this manual to the letter, you're going to get the assay done perfectly. So this is going to be very specific allelic discrimination, and we are using Tuckman assay system. It comes set up with the different alleles tagged with different fluorophores. One is tagged with the Vic fluorophore and one is tagged with the FAM fluorophore. So that is going to give us a very good allelic discrimination of either one allele or the other, or both alleles. And so after we set up this experiment, we are going to walk you through the real-time PCR machine system. For the most part, it's going to follow this manual, but we are going to make sure that you can be able to follow this procedure when you view this video, and I hope that would be helpful. So with that, we are going to move to the location of the PCR machine and proceed from there. Thank you. Okay, so we are setting up the genotyping assay for allelic discrimination, and to do that we have to set up a template. So our total reaction volume for every reaction is 5 microliters, and in that 5 microliters we're going to add 2.5 microliters of master mix and 0.25 microliters of the genotyping assay mix. The rest of the volume will depend on how much concentration of DNA you want to add, and then the difference you top up with the sterile water. So what you have to do first is to do calculation and see how many samples do you have, and you have to add all the samples and get the total volume. So you want to make a master mix of the Tuckman mix and the genotyping assay, and then you aliquot that in each tube, because pipetting 0.25 microliters can be sometimes challenging. You want to add all of them and the master mix in one tube, and then aliquot in each well on the assay plate, and then you determine how much DNA. Like in this case, we are going to use 2.25 micrograms of DNA, and our DNA concentration is nanograms of DNA, and our DNA concentration is 1 nanogram per microliter. So we add 2.25 microliters of DNA, and now we don't add water. If we were going to use 1 nanogram of DNA, we would have added 1 microliter of DNA and then 1.25 microliters of water to make the volume to 5. So after setting up the assay template, you add everything. So you add the master mix and the assay mix in one tube, and if you are going to use the same amount of water, you can add that as well and aliquot that in the assay tubes. And then for the DNA sample, you'd have to add that separately, and when you are adding the DNA samples, make sure to change the tip on every plate, and you, for the most part, you have to organize the plate in a way that you are comfortable with, so that you don't miss some wells, or you add double aliquots in one well. In this case, we have written the numbers of the wells and pasted it across the plate just to make it clear and easy that we add the correct amount in the correct well. And then after that, we're going to seal that plate tight with an adhesive seal and then spin it down briefly, and then take it to the this is the adhesive seal. We're gonna peel it out and seal it completely, and then spin it down and then take it to the 7900 HT real-time fast PCR machine and proceed from there. So we're gonna do this today. We are doing 3 different snips for 1 gene. That should help. 7900 HT fast real-time PCR machine that we're going to use, and it is connected to this computer, so we can drive it from the computer here. And getting ready to set up, I'm gonna let Jing and Emine walk you through the whole system, the way it is going to be set up and run. So with that, Jing and Emine are gonna go ahead and set that up.
Thank you.
So this is our plate, like 384 wells. So this time we put 5 snips in this plate. So next I'm gonna show you how to proceed the procedures. So first we need to open the Techman Snip genotyping software. And click OK. Then new plate wizard. And choose allelic discrimination. Click next. Finish. Next. And then create the plate. So the first is fast KD3RS
9259.
9259. And the second
RS 7052. 52
52. The third one
is RS 7580. AHQ, and the second one is 8420.
and then we create a marker for each snake. You can choose a color here for the marker.
Yes, just make sure it's different than white or something, so you can see on your plate when you are done. The change is C to T, and C is Vic, T is Fem in our case.
Vic, we can choose Vic CC and
T. repeat this step for each snaps that we have, but actually we run the analysis before, so that's why we have existing markers already for the specific snaps. And the second cascaded snap is 7052, which is C to T. C is Vic and T is Fem.
So it's showing the markers already exist.
Yes, we say okay. And okay.
So we can find it in the marker manager. If maybe someone already created one before.
Probably us.
So yeah.
RS 7052.
So we can search from the marker manager. Click enter.
There we
And
go.
we need to double check if they created the right one, like C to T.
Yes.
And we can just click and copy to plate document and OK and done. And next, actually we can search first to see if we're already
Mm-hmm.
5, 8. And C to T, we can just copy and done. This snap is C to T.
So basically, if you don't have the snap in the list, so we are creating our markers. But if we have our snaps, someone maybe defined already earlier. So we just use a marker manager and type the name of snap that we are looking. So then go from there. And here's the last one for WDR3.
So we don't have this markers.
Yeah, we need to create the marker. Same step.
And C to G.
Put the name, choose your color, and look at the change on UCSC. In our case, it's C to G. C is Vic and G is Fem. And there we go.
So now we have 5.
Yes.
And next, and then we select wells. So first name is from A1 to C4.
Yes. So we had 50 samples plus genotype, genomic DNA plus water. So we ended up having 52 wells. And each row in this plate has 24 wells. So we just choose wherever our samples is A through C.
And then we select the snake.
Yeah, first snap was 9259, and the same below samples in selected wells. And for the rest of the wells, we are going to do the same thing.
Oh, also for water, the last one.
Yes.
here we change unknown to NTC. So water change unknown to NTC.
It's just for water, including genomic DNA. We have to keep whatever we use as marker. Okay, we complete all the snaps, which are 5. Now we are ready to finish it. We can see how we have different colors that we choose for each snaps. And here is the list of snaps with their detector, like markers.
This is a plate.
Yes.
And we also can see the details from here. We can double check if the water is marked as NTC here. Okay, and then we need to save this file.
Usually we put the name of genes and the snap numbers.
And date.
Yes.
June
June 14th.
And then we can open another new plate with
Hold on.
and choose standard crop. Next. Then we can just choose the existing plate from the
We are just looking whatever we just saved. So it was Pascade 3 with 3 snaps plus WDR3, yes, with the date.
the existing plate.
Choose the same one again.
Then next.
We are going to repeat well selection here for each snap and define their marker.
This one is C to T.
And the snap is 9259. And don't forget the last one is water. It's gonna be NTC instead of unknown for both markers. $72.52 T. For water we do the same step, just change it to NTC. By clicking on them, you can see the task section is changing. And our third snap is 7580. It is C to T. Task 83, 7580, C to T. And the last one is NTC. And the fourth one is AHQ, C to T. Yes, AHQ. The last one is water. And our last snap is WDR 8420. It is C to G. And last one is water. Okay.
Finish. So next, we're gonna click on instrument. And we need to delete the first stage and change the 95 to 92. Check the time, 10 minutes, 15 seconds, and 1 minute. 40 seconds.
For the repeats.
And then we need to save this. Same name, amplification.
The only difference is for the second setup, we make sure we save it as the same name with the extension of ampli, because when we do post read, we are gonna need it.
And click on real time.
Real time is just below instrument. You can see, and yeah,
And connect to instrument.
this let us communicate with the machine. Now we are connected. We need to open the machine first. As we can see, the door will be opening, and we are going to put our plate.
And remember to check the plate, the location 1 and 8.
Yes, on top we need to see numbers, and on the left side we need to see the alphabets.
And click stop run.
You just click the start run here. On the upper side you can see instrument status showing us what has been done. Although we click on start run, we have to wait a little bit more until we see the time, how much left, because sometimes it doesn't work and you just waste your time. There we go. We see runtime remaining 128 here. So that is to tell us we need to wait 1.5 hours for this machine to run everything, and we will be doing post read next in the next video. Thank you.
This step is post read. We click on file and open the first file we saved before. This one. And click on instrument and connect and post read. All makers and 2 cluster column enabled. Apply. Okay. And then analysis.
And here's the result for 5 snaps, how they clustered and with the volume.